Hello the internet, my name is Wesley and this is episode 13 of my Donation Synth series. I'm building piece by piece a DIY modular synthesizer in the Cosmo format using 3D printed panels that I'm going to be donating to the Synthesizer Library of Portland. So if you're in the Portland area and you visit the Synth Library, you could play this thing in real life if you're interested in modular. I'm really excited about this project, and I'm really also glad to be nearly done. And this module that I'm showing off is one that I have been working really hard on. I have a prototype that's been in my rack for a couple years, and now I've built a far more refined version of it that's going in the Donation Synth. So this module is a Midi to control voltage converter. A brief explanation of what that is. Essentially, a keyboard like this one is able to report the position of all these knobs and all these sliders and whether a key is pressed or not. It reports all that down one little cable called a Midi cable. And essentially, it just says, like, this key was pressed, at this time, it was released at this time, it was pressed with this velocity, and that's all digital information that goes into the module that I've built here, and then the module interprets that and outputs the correct analog voltages to drive the synthesizer to do everything that you would expect. So this keyboard doesn't make any noise by itself, it's just saying when a key has been pressed to the module. And then the module outputs all the voltages to make all that other stuff happen. So in the corner over here is a camera that's up very close on the tiny little menu system that's on here. It's pretty easy to see with your eyes, but it can be a little bit difficult on camera. It's just the camera doesn't really like it very much. But in any case, you can see that it says preset 1. So right now I've got preset 1 set up to play all the oscillators together in a big stack. But if I flip to preset 2, now it's going to split things up so that, like, the bass down here is one voice and everything else is on another voice. All the settings, except for a few global settings, can be adjusted through this little switch that grabs your different presets. And you can access more presets than the physical UI has room for by sending it MIDI program changes, and that's something you can toggle on and off in the menus. So if this looks a little bit tedious to set up, I won't deny that there is like a small amount of tedium on the initial setup, but my rationale here is that for all the flexibility that you can get, it's better to like front load the tedium into a 20 or so minute setup session and then just have exactly what you want available at the press of a switch. So once I've got my settings in there, I usually don't touch them. It just does what I want every time I fire it up. It's got maybe 2 or 3 different things I'd want. And I do have like a rotary encoder with 10 presets on it on my other prototype, but I find I just use the first 3 pretty much every time with only minor changes, so I figured just simplify it, get it down to a single switch that has 3 on there. There are a lot of DIY MIDI to control voltage modules out there, but I feel like mine brings some new stuff to the table that I haven't seen before, so let's scroll all the way down here to the MIDI monitor. So a lot of times on a MIDI controller like this one, it's kind of hard to know what's happening. So I've set this up to where, like, anything that I press, it'll tell you what it's doing. So there on the menu, you can see that the source is the 5-pin MIDI connection. There's also a USB MIDI connection, which is class compliant, so it'll work for your DAW or like an MPC or whatever without any additional drivers. It tells you the channel, which right now is channel 2. It tells you the velocity, the note number, etc. Okay, but it's not just notes that'll tell you what's going on. Like, for example, if I mush here, it'll tell me that we're getting aftertouch, because this is an aftertouch sensitive keyboard, and tells you the value and everything. I can do the mod wheel, and it says control change number, what do we got here, number 2. Then if I move pitch bend, it'll tell you, that it's pitch bend, what channel it's on, etc. And where I find this really helpful is, like, all these random knobs and stuff and these pads over here, I have like no idea what they do, but using this MIDI monitor feature, I can just wiggle any slider and it tells me exactly what it is, what channel it's on, what CC number it is. But that's just for retrieving information. We want to actually do some stuff here. So basically there are, on this model, 8 control voltage outputs, but you can easily scale the circuit and the code to accommodate a lot more than that. But that's kind of just the right number for this project. So CV out 1, 2, 3, 4, you can see it goes all the way up to 8, and then there's a back button. So let's go to number 1, click on it, and you can see it says function note, but we can scroll through all kinds of different functions. There's note, control change, and this is basically like what it's going to react to and output a voltage in response to. Velocity, that's like how hard you hit the key, the mod wheel, pitch bend, etc. And then there's learn mode. So I'm going to go ahead and click on learn mode right now. And so when I press a key, it knows that it should be on, or like reacting to notes. And it also knows that it should react to the main MIDI channel, which we can define on the main menu. So another thing that you'll see here is prior, which is short for priority. So right now it's on high note priority. So if I go and press other keys, it's only the highest note that will sound. But what I can do is go from high to low note priority, and now it's the other way. Or you can alternately change that to be on last note priority. So it's whichever note is the most recent is always going to take priority. So there's like interesting things you can do where if you have multiple oscillators, they can have different note priorities and stuff like that. There is also a scale factor. So like if the tuning on your oscillator isn't like perfectly nailed because the components within the converter have like a 1% tolerance, you can adjust it using this little scale factor here. There's also like a pitch bend function, which is a little bit grainy. Like with a little bit of slew rate, it sounds alright, but just raw, it's like... You can kind of hear the steps in there, but you know, if you add a little bit of slew rate limiting to it, it goes pretty smooth. And that pitch bend amount you can define. So right now it's on 7 semitones. You could crank it all the way up to 12, say, and have it be an octave. Or you could crank it down to just a couple semitones, right? Here's 3. Keep in mind that note function will also allow you to add things like keyboard tracking to any other variable. It doesn't just have to be for the volt per octave input of an oscillator, but that is the main usage of it. So let's go through some other things. So I'm going to go ahead and plug a cable into control voltage output number 4 here, and let's do something with it. So why don't I just go ahead and assign that to the mod wheel. So let's go to control voltage. I'll scroll all the way to number 8. Right now it's on aftertouch, but what I'm going to do is either scroll to the mod wheel, or what I can do is go to Midi learn mode. So when I go to learn mode, I just wiggle the mod wheel, and boom, it knows that whatever I put down this cable should react to the mod wheel now. So let me just plug it into, for example, the filter cutoff. So pretty dark, right? And now I can manually control the position of that filter using this wheel. You can hear it's a little bit steppy, so if you have a slew rate limiter you can use that, and there is one built into this module. Okay, that's great, but what if I wanted to have that be assigned to, for example, the pitch bend? So let's go back in here. And I know this menu looks very tedious, but with my camera 2 inches in front of there, it's very difficult for me to access, but normally that won't be a problem. So I'll go to control voltage number 8, and now from the mod I'm just going to go to MIDI learn again, and then wiggle the pitch bend wheel, and now it's that same thing is set to the pitch bend wheel. So because the voltages can be a little steppy because of the nature of MIDI, what I'm doing is just putting it through this little attenuverter module that we talked about in my previous episode to just kind of like compress those values a little bit. So it just sounds a little bit smoother. But there's still a lot else you can do. Like if I wanted to take one of these knobs and have that control the filter, right? I just go into control voltage, hit up number 8, go to learn mode, and just wiggle whatever I want. So now this knob is what controls the filter. So not everything on an analog synthesizer wants an analog voltage out. Sometimes you just want a pulse, just like a 5 volt yes, no, on or off signal. So usually that's going to be something like an envelope generator. It receives a 5-volt pulse, and as long as that pulse is active, then the envelope generator is going to be doing its thing. So we can do that using our control voltage menu. Like if I wanted to take number 8, instead of having it be a CC, I could make it be, let's see, a gate or trigger. But we also have dedicated gate and trigger outputs on here because they're so much electrically simpler. I just included 4 outputs that only do gate and trigger. So if I go back and then go over to the second menu item, gate and trig, instead of being 1 through 8, they're A, B, C, D. And we can do the same thing. Like we just go down here to function, and gate means that it's going to pulse high as long as I hold the key. Trigger means it's just going to pulse high for a moment, and then that's it. So right now, gate A is set to trigger an envelope that's affecting the cutoff frequency of a filter. That's going to happen through gate A. So I'm going to go to gate/trig, go to A, and right now it's set to gate. I'll set it to trigger. So now it doesn't matter how long I hold it, it just goes and just pulses for a few milliseconds. But if I go in there and switch it back to gate, now there are 2 additional functions here. There's always on and always off. So if you wanted to disable or permanently enable it, you can do it through that menu. And the reason I've done that is because I have some voltage controlled relay modules, so that when you toggle through presets, it can automatically reroute the signal in your synthesizer. I haven't built those into this synth, but in my daily driver rack I have some of those, so it like moves oscillators around and stuff. And so basically the always on, always off allows you to do that kind of thing. And of course we can go here to learn mode as well and just tap a key, and then it'll go to gate on the channel that we want. Since we've defined in the main menu that the main MIDI channel is going to be channel 2, anytime it receives a message on channel 2, it just snaps to the main MIDI channel here. But of course if you want it, you can set it manually to be whatever, or to be omni, so that it just like reacts to any channel. Or it can be like main channel +1, main channel +2, etc. So it's important to keep in mind that in the gate/trigger menu, they can only pulse high or low. They can't do intermediate values because the physical circuit is different. And it's just a lot simpler, so I included some that have that limitation because you're always going to need some anyway. So like, why put a $6 DAC on every single one of them if it doesn't need it, was my rationale. So we've talked about the control voltage menu, we've talked about the gate/trig menu. Now let's talk about the copy preset menu. So a lot of times your presets are going to be very similar with just little differences in between, like changing up, the destination of your modulation wheel, or making it, so that you're like all your voices are together, versus making it so that you've just got one voice, that kind of thing. So I can take a preset and copy it. So I'm just going to go copy preset. So copy current preset number 2 into preset slot number 3. So I'm still in 2, but now when I move to 3, it's the same as 2. So almost everything is per preset except for the main MIDI channel is a global feature, and the scale factor on your oscillators to make sure that they're in tune. That's global because of course you're not going to want to be in tune on some presets and out of tune on other presets. Alright, so we've shown off control voltage, we've shown off gate trig, we've shown off copy preset. Now this main MIDI channel thing here, we can do a few different things. So we can go to the MIDI learn thing and just tap something and it'll set the main MIDI channel to wherever we're at. In this case it's 2. But there is another hidden menu item here too. So if I click it again, it's going to go to this option that says Enable MIDI Presets. I don't know how visible that is. It's a lot more legible in real life. But if I click on it, now we've expanded the number of possible presets past just what we've got here on this little toggle switch. So now that we've enabled MIDI presets, I've got Ableton Live plugged into this thing, and if I set the track to do a preset change, I hit play, and you can see it's gone to preset 19, which is way outside the range of what's available on the physical switches, but if I toggle them, then they'll jump back down to the 1 to 3 range that's available on the physical selector. So basically the number of presets is limited by the number of EEPROM addresses that are available on the Teensy 4.1 that this thing is based on. But you could probably go up to maybe like 80 or so before you run out of memory. And that's just like an arbitrary number that you can, put when you're uploading the code. Those MIDI program changes need to be on the main MIDI channel, by the way. But if we're getting confusing program change messages and you don't want that, you can just go into the main MIDI channel and scroll around until we get to disable MIDI presets, and then once you click on that, I can send the message again, and you can see like nothing happens. So pulling the camera back a little bit, now we can see the entire module, and I can tell you a little bit about what's on the front panel of this thing. So this is our preset selector switch here. The menu happens through this rotary encoder. You can spin it or push it in to get a button press. And these top 4 outputs here are all for control voltage, and they're all routed through a 4-channel slew rate limiter that I'll talk about in a little bit. And these 4 outputs down here are also control voltage outputs that are not run through a slew rate limiter, so they're just like raw, values coming straight out. Beneath that, these 4 are gate and trigger outputs, or they can be set to always on, always off, and they're just high, low, yes, no, like 5-volt pulses essentially, because it didn't make sense to me to put a, $5 or $6 DAC behind every single one of them when it's not really necessary. Down here is a 5-pin, like old school style MIDI connector that does have an optical isolator on it to help you avoid ground loop noise, and if you're in a situation where that's not an issue, there's also a USB Type B connector like you would use to connect to a printer. And you can plug that in to connect with like an MPC or Ableton Live on your computer, whatever digital audio workstation you're into. And it's totally class compliant, so you won't need to download any special drivers or anything to connect to it. It'll just appear as like Teensy 4.1 MIDI or whatever. Next up, this little knob up here is a 4-channel slew rate limiter that affects all of this top row of outputs. So normally when you like play a note, here, let's give an example. You can hear it cleanly moving between those notes, boop, boop. But if I increase the slew rate limiter here, now you have an effect called portamento, and the more I crank it up, the more time it takes to get between them. So I can add just a little. And you can kind of ride that control in real time. And these little switches here control which of these outputs is going through the slew rate limiter. So this switch is for the 2 leftmost, these top left outputs here. And so if I have the slew rate limiter up and that switch is up, but if I flip it down, and that makes it so that if you have more than one voice, they're not all going to be slew rate limited. So for example, say I flip just this on, and now only these 2 are going through the slew rate limiter. Slew rate limiting on one voice, but not the other. Right? And then one's moving cleanly, and you can be playing them both at the same time and not, have them contradict each other. Yep, and then let's say, I just want them all to play the same thing at the same time, right? Well, I change the preset on my keyboard here and the preset down here. And now that they're all playing together, we still have one layer moving sharply between the notes and the other one moving through the slew rate limiter. I don't know if you can hear that, but there's one that's going da-da and one that's going da-wah. So I think that's like a really interesting way to layer things, which is kind of why I've put them all together on one control. Now they all move together. thought that was kind of an interesting performance control and something that I always wished I had on my prototype, so I implemented it here. But if you wanted to have like a more detailed slew rate limiting schema, you could, build something else in your own rack. And it is also useful for like smoothing things out. Like, for example, if I want to have a little bit of pitch bend, like having a little bit of slew rate limiting makes the pitch bend sound a little bit more natural. And since not all of these outputs are being used, I could do something like if I wanted to control the filter. Now we're getting a much smoother response. Like those 127 MIDI values sound a lot smoother when there's a little bit of slew rate limiting on there. So you could also configure it that way to just have only like control voltages going through there that are like for tweaking parameters or whatever. It's kind of all up to you. So I think that covers everything that this thing does. I know it seems a little bit tedious, but I was really trying to front load the tedium so that like after like 30 minutes of setup, or I think probably less, once you get it set up and you've got your like kind of main patches that you go to, you're pretty much good to go after that. And you can really, like, I've been using the filter as my example, but you could take any of these and link it into anything that has a CV input. It could be LFO speed. You could use it in a VCA so that you're letting an LFO through in like a sort of predefined amount, and you can sequence all that through your DAW or a sequencer, MPC, whatever it is. You can have those like movements of parameters like predefined so that you can be kind of hands off or only ride certain controls or kind of set something up to play while you play another instrument. So I think this is like really powerful. I really like it a lot. I'm super proud of it. There's a couple things I would like to do, like implement the pitch bend in a less like steppy way. I would like to have per channel slew rate limiting in like a simpler like kind of way that I could just like trim with like a little trim pot or something to just smooth everything out. And I'd like to be able to do like negative voltages and stuff, but right now I think this is a great start. I think this is like a more complicated build, but also like more powerful than a lot of the DIY projects that I've seen floating around out there, so I'm hoping like someone will be interested in this. So if you're interested in building this yourself, you can go to my GitHub page where all the resources are there. You've got the INO file for programming the board, and then for the main board and the slew rate limiter, you've got schematics here, and you've also got production files. So you're just going to take this zip file, you download it, and then you just take the zip file from your download, and you're going to take it over to JLC PCB, and then you literally just put it in the add Gerber file. Pretty much keep all the defaults the same, and you're good to go. The code for the Teensy 4.1 is going to be on there. I do plan to move this project over to a Teensy 4.0, which I think is a more appropriate platform. I plan on changing the circuit a little bit, refining the code. So we're here, this thing's good, it works. But I think like around the corner is an even more refined version. So, if you're hard up for something, this is a great build. But, if you don't mind waiting, stick around, and hopefully sometime the next year or so, I'll crank out an even more refined version that has like a monolithic construction style rather than doing all the offboard wiring that's on this one. So thanks for sticking with me. This is currently the only one of these units that exists, and it's going to be at the Synthesizer Library of Portland. And I welcome any feedback. Anyway, I've been Wesley, and consider subscribing if you want original music, more like synthesizer inventions and that kind of thing. Thank you, and have a great day. Goodbye.